Hey everyone, how's it going?
Hey, Dan.
Good evening.
Let me share the little agenda I had, and we can go from there. Okay, so yeah, I was actually looking at some other options before I got on the call here, but any opens people want to add to this besides what they kind of see here? I was thinking we spend most of the time just walking through what's in that patch set, make sure we're on the same page, see if it's suitable, not suitable, gaps, next steps, and then when I spend some time making sure we're all on the same page about the lock to run atomicity, like making sure that we all are on the same page. Like, hey, all these mechanisms. It sounds like all these mechanisms are converging. That if so, we'll go through that. Um, this next bullet is just an idea about, hey, if we have common evidence, why do we need to make the guest request interface handle those big blobs? Maybe we don't need to. That could be something else common. And then start talking through next steps for phase 3 things. Anything else to add to the list?
I think it would be good to discuss what should we do with IOMMUFD and DMA buff patches. If you can kind of like put them in some, probably you can collect them in the tree and then we can all converge.
Yep. That's kind of my that's the deep my my term for that collection of things is called phase 3, which is
Okay,
yeah. But
okay.
yeah, but same thing. But yes, we should do that. Okay. So I'll walk through what went out real quick because I don't know if Dave, if you've been able to see what was on the list just recently for.
Unless it's the SPDM patch set that you've linked me to, I haven't seen anything else besides that. What topic in particular was
So the yeah the piece that we wanted to talk about was this new evidence interface. I can bring up the patches here, but there.
Is this the proof of concept that you mentioned in the SPDM patch set discussion, or is this something different than that?
This is So this is the SPDM patch discussion. That is the Rust library basically taking over for what Lucas did.
Yeah.
And in the patch that I put out this week, it was a counter proposal.
Okay, so I haven't seen your new patch set. I
Okay.
appreciate it if you could send me a link. Was it on the confidential compute mailing list, or was it on the regular LKML mailing
No,
list?
it was from the on the Linux Cocoa list.
Okay, so I should have it. I just need to look for it. Then.
Yeah, I'll put the link in the chat here real quick. Here, let's see. And this one. Let me go ahead and share this. Let's see, am I on the right screen here?
Okay, yeah. So I am seeing that here. The PCI TSM TEIO infrastructure patch list.
Yep, that one. Yeah, I'll put that in the chat.
Okay.
So I think the most relevant thing here for what you and Matthew took a look at is this patch PCI TSM add evidence support. I'll
Okay.
put that in the. I'll put that in also in the chat. The exact patch, but
Which patch numbers?
this was
It's patch 8. Okay.
patch 8. Yeah. So
I
so
got it
so
right here.
patch 8 adds a netlink interface for just grabbing everything. You can basically ask it to dump all objects it knows about, and these objects are like the certificate blobs, the measurements, the interface report. Um, Anish, I'm guessing that VCA. I didn't see that term in like any of any documents, but I'm assuming that means that that's the
SPDM
It's an
spec talk.
SPDM spec. Yeah.
It's SPDM spec talks about that. So in
okay,
order to generate the measurement, in order to generate the signature, you need VCA.
which is just the
Yeah. It
version
stands for
capability algorithms.
version
Yes,
capabilities algorithms.
yes,
Yeah.
yeah.
Okay. So
So that's the
it's just
very
that.
beginning of the transcript. It's the
Okay,
VCA, and then it's every
Yeah.
get measurement request and response added to the transcript after that. So it's VCA requests and responses, and then each measurement that you ask before you get the final signed measurement. Now, if you only do one signed measurement, it's VCA concatenated with that one measurement request and response that's signed. The whole thing is signed, but yeah,
one signature. Yeah,
yeah,
because like the like TDX doesn't give you a separate VCA object; they just give you the full transcript of measurements, whereas
Mhm.
CCA breaks out VCA, it's a separate thing you can request separate from the measurements. And so, but basically, this netlink interface can just do it all.
Mhm.
Um, on the on like in Lucas's, he does a multicast message of all the new signatures. In this one, we just say no, we're not doing signature validation in the kernel. We're not doing anything in the kernel
Yeah.
except dumping these things. And then the user space can make all the decisions about these blobs.
Okay. And is there a remeasurement portion to the netlink interface where you could request a new measurement with a nonce and get the whole blob back? Or
Correct. So the idea is that yeah, so you can request anything at any time. Basically, it
Mhm.
would be the last thing that was ever requested will be repeated back, um, and then if you want to for the ones that take nonces, if you supply a nonce, then the idea is that it will refresh that blob with a nonce, and then
Okay.
you can fetch it again. Um, so yeah, so th- this is a netlink dump interface. You can pass
Mhm.
all the types you want, dump those back out. And then if you want to, when you're dumping, you can either dump them with a nonce or without, and the nonce just means that the thing that's coming out is going to, yeah, is going to have the nonce included with the new signature.
What do you mean by evidence type?
Evidence type is these. It's just an index number of which objects that this interface supports. So you can
Okay.
dump certificate slots, you can dump ECA measurements, or the interface report, or all of them. Whatever is present,
Okay.
it'll dump out.
But I thought you said you can't get the VCA separate from the whole transcript
Well,
because of the
it
TDX
depends on the.
on the
Well, yeah,
TSM that's implementing it.
correct. Right.
Okay.
So it's going to be the
So
case
is
that
report what we request as for a TDX use case? We just grab report and get everything back, or is that the TDS report portion of it?
um, you get the so if we're on TDX, you'll never see anything but measurements and certificates, and the interface report. the VCA will not be independently retrievable with a signature. So that's just like a detail that user space is going to have to handle. It's like, oh, hey, sometimes you can get your measurements for the signature, and sometimes you can get the VCA by itself with its own signature. But if you don't get it, then user space, you got to figure it out. But
Well, you'll
it's not
never
like
get the assigned VCA, right? Because the VCA isn't what gets signed. What gets signed in an SPDM measurement request is VCA concatenated with all the measurement requests and responses, and that whole hash is signed at the end. So the VCA would just allow you to independently calculate the hash on your end. But if you're just given a whole transcript blob, you'd be able to do that on your own anyway, right? Because the first six messages would be VCA requests and responses. It concatenated them with your measurement request, and then you'd be able to reconstruct the signature based on the certs.
but so I mean, maybe Anisha can correct me if I'm wrong, but I was thinking that like if you not yes, if you do a measurement request, you get the
Yeah, I don't.
VCA
No,
concatenated, and
no,
but if you
no.
don't, okay, no.
In my case, no. Like in my case, get measurements will give me measurements alone. So there are different options for requesting for get measurements. I don't think we are exposing the second one, which is getting the hash. So I get a raw bit stream of the measurements, which is full transcript. If the device supports signing capability, it will be signed. So what we can ask is give me the raw bit stream, and that includes not including VCA, the request and the response, the full one. And if the device supports signing, it will sign. There will be a hash and then the signature, right? So that's what the measurement reports. So in order to validate it, the user space has to request for VCA, take the first part of the get measurement response, concatenate it, sign it, and then compare it with the signature.
Okay, so you're treating the measurements type here as the equivalent of a get measurements request
Okay, exactly,
response
exactly,
in
exactly,
the SPDM spec.
exactly, exactly.
But we have no way of supporting that in TDX world. We just get the whole thing back.
You get the whole thing back.
Yeah.
Uh,
So the
that
reason
makes
why
flows
we,
kind of difficult to
yeah, the
make it kind
reason,
of like a generic user space agent for this then, right? Because now we have to be
But
yeah,
TSM
yeah.
specific for just getting evidence, which doesn't seem like a good idea.
well, I mean, wait, you still get you can still get either this is just the VCA with a signature, like just like so not the measurement request, but just the session establishment. Isn't the session establishment? Can you just get a transcript of that? And that's just a challenge response signature with the VCA.
But it's potentially more than the VCA, right?
It's probably a little bit more than
Because
the
if you
VCA.
have a mutually authenticated session establishment, you'll have more inside that
That's true,
transcript than just VCA.
So
right?
if I can ask, so the way this is done in CCA is whatever comes from the device response is in a way getting cached in the host, right? This is, as it is, the firmware doesn't spend much time trying to add anything more or. So the VCA is something that's collected during the session establishments, right?
Mhm.
And the get measurement SPDM request. So when you say you would give back the guest the complete one. Who is concatenating it? Is the firmware concatenating? Is the host concatenating?
I mean, doesn't whoever is generating the signature have to do the concatenation? I would have thought that the firmware is doing the concatenation to generate the signature. It's
Okay,
not
so
like Linux.
it's
Linux is not doing it, right?
Well, the DSM, so the DSM will create the signature on the get measurement response, right?
Uh-huh. Uh-huh.
Because the device is the only one who can do that because it's the only one who has the
Yeah. Private
private
key.
keys.
Yeah.
yeah, I'm not checking with the signature. The get measurement, the VCA at the beginning of the get measurements in this case, right? In the netlink,
Mhm.
who put that VCA at the front? Because it's not
The
SPDM response,
It's not SPDM
get
response.
measurement response.
I see you're saying like
Yeah.
the payload that was negotiated though for VCA was something that the TSM added.
Okay, and
Well,
that's
that's I'm
the
asking.
Yeah. Yeah, because the VCA is like you said, part of the session establishment. So normally what would
Yeah.
happen is when you're doing your version, your certificates, your algorithms, or capabilities, your algorithms, rather, uh, you would save that off separate because in
yeah.
reality, when you do, but to be fair, it's probably the device, the DSM saving that VCA off. for the most part, and just so it has a copy of it, so it can
Exactly.
make signatures appropriately for the measurements
Ex
request. But
exactly.
yeah, but
Now the question is, for the get measurement netlink interface, we got a response which had VCA at the beginning on TDX, right?
mhm.
So the response we got for get measurement netlink is TDX followed by the full transcript, and VCA followed by the full transcript. I'm just trying to understand in TDX who added the VCA at the beginning of the transcript, in front of transcript. Is that the
Well,
firmware?
the transcript starts with the VCA. The transcript that is given for an SPM get measurement, it contains the VCA and then the
Oh,
request and
then
response for every single measurement request up until the final signed measurement request. Now, if it's your first measurement request is a signed measurement request, the transcript's going to contain your VCA plus your request and your
oh,
response with the flag in
I
that request saying, I want this measurement to be signed.
okay. So I think I have some confusion there. I will go back and check the spec because I somehow thought that the response for SPDM get measurements only included the full transcript, not the VCA at the front. But you are saying that the DSM itself will give me back VCA plus the request plus the response, right? The full transcript is
Well,
VCA.
yeah, that's the transcript it uses to calculate the signature. It's VCA plus every single,
That I
yeah,
understand. I'm just
yeah.
wondering whether SPDM get measurements response from DCM includes VCA. I was thinking
No,
it
it
won't.
shouldn't. Yeah, it should only include the individual response to the get measurement request that you asked for.
Exactly.
That,
With that condition on TDX, who added VCA? I mean, I'm just trying to understand what we are saying is the netlink type measurements would get me back with VCA is what Dan is saying, right?
yeah, and this is I think a limitation of the TDX ABI, is basically when we get evidence, the evidence we get back for TDI is the full transcript, is my understanding.
Okay, so
It's
the
it's
firmware
not
TDX.
just
Okay,
the response to the get measurement request. It's a
okay.
something went off and did the get measurement request on our behalf, and when we say give me the device quote for this device, it gives me back the transcript.
Okay. Okay. Because in our case, the firmware doesn't do any sort of caching of this get measurement response. So there is nothing in the firmware. So firmware only keep a digest to let the guest to compare and make sure it is indeed what the firmware got. So while the response is coming from the device, we send it for caching in the hypervisor, right? So there is no VCA since the SPDM get measurements is. So that's why VCA ends up as a separate object for me.
But but is the but is VCA? I guess the question is VCA going to be? I guess I need to look and see if TDX is calculating the signature over the VCA bytes, or the VCA
It,
bytes only are the signature is only calculated over the get measurements part of the
no,
transcript.
it has to
So
calculate for
the
the full
TDX
one as
doesn't
per
do
the
that.
spec.
Yeah, but
The
TDX isn't the
DS,
one calculating the signature, right?
DSM, yeah.
Yeah, the DSM on the device calculates the signature. The only thing is TDX needs to make available the VCA and the responses to the measurement requests, however they're done, so that whoever receives all of this data can validate the transcript, or essentially the transcript that it's given, right?
Mhm.
So user space can verify that, hey, you told me that this is the signature on this measurement request, and you did it. The problem is that the measurement functionality in SPDM is flexible enough to be a problem, but not flexible enough to be like very useful. So
Right.
you get
And
these weird situations where you could say, "Give me these five things unsigned," and then sign the last one, and then you have to construct everything by hand to know that the signature you're getting back on that final measurement request matches the whole transcript of the VCA plus, the first five requests response pairs, and then the final request response pair, which is actually signed.
yeah, yeah, and these are the differences where I'm just like, there's absolutely no way that the kernel can, especially because there's so much optionality and everybody kind of does
Yeah.
this a little bit differently. So
Hmm.
what the interface is basically saying is like, hey, you probably want to ask for these two things.
Yeah.
Um,
And the
and if
TS
you,
report. Yeah.
yeah, well, I mean, well, yeah, all these things. It might be the case that depending on who you're talking to, you'll get only these only these bottom two, and it'll happen that the BCA is part of this transcript. That's your user space job. You got to figure it out. Or you might find that, okay, actually no, this doesn't have the BCA in this transcript. It has a signature of this by itself, and if you need to know the BCA, that will come in separately. But so it's not quite as bad as if TDX do this, if CCA do that. It's still based on how the kernel populates these objects. But yeah, you can probably detect which TSM you're on just based on how it responds to asking for these three things.
Yeah, but as far as the user space API goes, that's not ideal, right? I shouldn't have to poke and prod and find out the exact. Like if the idea here is we want to be standard compliant, we're having to poke and prod the individual implementation of the standard to find out what idiosyncrasies are. To just parse a measurement is not very ideal.
So
and I don't know if this means maybe we got to go to our TDX people and say, hey, in this TDX ABI that we have, we really should be separating out these two components of the SPDM response so that people can actually deal with it in a more standard compliant way rather than just the whole blob.
I mean, as long as the blob is standard, SPDM standard, I think it's like, and because the SPDM standard itself is saying, yeah, you can be optional. You can combine these things. You can leave it out or keep it in. That's SPDM optionality. So I think this is kind of par for the course for what SPDM has to, or what SPDM throws at us. And just to be clear on what it would take to ask for everything and not care about which TSM you're on, it's just one. So this is the kernel test script for
the network CLI
for grabbing stuff, and this mask is just everything. So it says grab everything. And as far as the objects come back, it'll tell you which objects come back. So it's just parsing JSON. So I don't think it's I think it's an if statement. I don't think it's like in terms of ABI kernels, like, yeah, I gave you everything you wanted.
Yeah.
And it's in a standard SPDM format. So good luck.
Yeah, maybe that's the answer. Grab everything, because the VCA will always be there, regardless of whether or not you have a signed measurement.
Yes. Yeah.
The transcript will always contain a VCA, because otherwise you wouldn't know how to handle the measurements, regardless of whether or not they're signed. Because the checksums inside the measurement responses, you need the A to know what format you're getting back. So you always have to have the VCA as part of a transcript.
But the VCA can change per get measurements call.
No, it is constant across all sessions, all calls within the session. So if you had two different sessions, though, you'd have two different VCAs potentially.
Right. But I think it's what CCA is saying is like, hey, we'll do the initial session establishment. We'll save off that VCA and never touch it again. You can grab it separately. TDX is saying we're not going to save it off, and next time you do get measurements, we'll give you the whole thing. That's okay.
Yeah, I guess. Yeah, and I guess you're right. It's basically request everything, and if you don't get something back for the VCA, assume that it's inside the measurement portion.
It's inside the measurement. Yeah.
Yeah, it's just a really weird interface though, because as an SPDM client, it's completely reasonable for me to say, give me a measurement of index 1 that's unsigned, give me a measurement of index 5 that's unsigned, give me a measurement of index 7 that's unsigned, give me a measurement of index 13 that's signed, right? And to have to parse that transcript, which contains VCA plus unsigned measurement, unsigned measurement, unsigned measurement, signed measurement, and toss out that VCA every time except for the very last one to reconstruct the transcript in user space to verify it, it just seems weird and clunky.
Okay. I mean, that's the piece that I think it would be worth talking to the TDX. But I'm assuming that at least, like, I know Alexi and I think all the implementations are not caring about asking for individual measurements. They just send the whole thing and expect users to figure it out.
We dropped the ability to do that. The firmware doesn't do that anymore. So the only API exposed by the firmware at this point is request for raw bit stream or hash.
Was it raw bit stream of everything or hash of everything?
Yeah.
And if you have like measurements them
signed or
mutate.
unsigned is dependent on the device capability. So the device can support signed measurements, it will give back signed by default. So it's
Okay,
not
so you
even
force signed measurements if it's
exact.
available, you force signed measurements. You don't give
Yes,
any
exact,
flexibility to the speed.
exact, exact.
Okay.
So,
Small
I mean,
note.
hmm, go ahead,
Uh,
Lucy.
this VCA thing, it's not literal 3 bytes VCA.
No, it's a
Uh,
bunch of bytes. It's
yeah,
it's the
get
get
version,
version
get
message. Yeah,
capabilities, and others.
yeah,
Yep.
yeah. But I think the responses are interleaved in between. I don't think it's the three requests and the three responses. I think it's version response, capability response, algorithm response.
Right.
Yeah, so it's a multi-byte section
That's what my
transcript.
PSP gives me. Yep.
Yeah. Mhm.
Um,
So maybe this goes
yeah,
back to what you were saying quite a bit, Dan, which is, you know, obviously the CCA and the confidential compute use cases are very different here, and maybe we don't provide the flexibility that a full SPDM implementation would provide
correct.
because we really only want a specific use case. The only thing I could see here that might be a problem is what happens if uh, you might have to handle the case where the size of the get measurements response is not possible to fit the over an individual SPDM message on the host side, and where you're going to have to do the multiple chunking of the messages. That I don't know if this patch set handles that or not.
That
It
will be
should hit,
done
well,
at the TSM side,
at the,
not at the core layer. The callback will handle that.
yeah. So we basically have a buffer, a buffer and a size. That's it. And each TSM driver can set if they need to reallocate or extend that buffer size, they can. And we have a lock that makes sure, like, hey, if you're trying to dump this thing while the TSM is touching it, you can't, or you got to wait, kind of thing. But yeah, it should be the case that if you need to go all the way up to the full 16 megabyte thing, you can, and this interface will handle it. So this is a nice feature of netlink dumping, is
Mm-hmm.
that you can just keep dumping, spitting out bytes over the interface. So it will get split over multiple messages over netlink, and you got to be like, hey, I'm retrieving this measurement object. Oh, it's still coming. I got more messages. It's still dumping out.
Yeah.
But it should all make it out.
Okay. Yeah, I'm less concerned with the netlink side of it and more of the DOE side of it.
On the DOE side, yeah, it would have to be the TSM driver that's chunking and assembling and putting it all into one nice buffer.
And
Uh,
the TSM, because in our case, it's the TX module that's handling the construction of these messages, right? Not the host.
I
So the
mean, the host is
TDX
involved,
module would
right?
have to know to chunk them up and to get the multiple responses.
Yes.
I guess it's going to have to know that regardless. So that makes
Yeah,
sense.
the firmware does it for CCA too.
Yeah.
Yeah. I mean, like the TDX API, or API,
Mm-hmm.
uh, just gives us here's the full transcript buffer. I think it is, and Yulun can correct me if I'm wrong. I mean, I think if it's probably going to be the case that we have to give the module 16 megabytes worth of pages so it can do the full transfer. If we ever got that big, I don't think we do need to do.
I'm hoping it never
Uh,
gets that big.
if you know off the top of your head, Yulun, you can let me know, or say I don't. We'd have to go look. But if if we allocate a static number of pages for the SPDM responses, or the driver is responsible for assembling multiple responses into one big buffer.
For the measurement,
Mm-hmm.
It should it's just to prepare one buffer, and the firmware will compose or the entire measurement. Yeah.
Okay. Okay.
We don't get it part by part.
Okay. So I think David, my ask would be to think about whether we can get away with the kernel being this simple, where it's just like, yeah, users, we're knowingly leaving a pile of mess for the user space to reassemble, but we think we've given user space the entire Lego set. This may be a not assembled Lego set. But yeah, if you think there's any more help that the user space side would absolutely need from the kernel, let me know and we can adjust. But this is kind of where we're at, saying if TSM driver offers object, spit it out. That's it. It's pretty straight. It's pretty pretty dumb. Okay. So related to this I updated the staging branch. That was 619 based. I'm gonna probably tomorrow, hopefully, knock on wood, I'll rebase it to 7.0 RC2. That shouldn't be too bad. But the thing I didn't include, Anish, was I didn't include the guest request fix-up on the response bytes so they could be updated. And because one, I just ran out of time, but two, I started thinking, hey, if we have all these objects in a common place and everybody, AMD, TDX, CCA, they all need to get these large 16 megabyte blobs potentially over into the guest, why would we have every single implementation reinvent how to get those blobs into a guest? I do understand that so we have AF VSOC for getting stuff across. If it's KVM, I do know that Hyper-V doesn't do that, so we might have to do an AF Hyper-V. But I feel like this is something that we could do in user space. That when you lock, as part of locking the device, you can inject the. I'm not even sure you need to inject it, right? Because if you can ask the host for the copy of the certificates for the device and the TSM driver will just give you the digest, then it's not even the kernel's problem to get those blobs across, right? You just have
So
your guest user space VSOC something or other grab blobs for a given device. You ask the kernel, hey, please give me the trusted digest for these things that I got through these other unsecure means, and off you go. You don't even need to ever dump
yeah,
a certificate from the kernel side.
Well,
so the
certificate
way
has to be a certificate, though. It can't be a digested certificate. I don't believe the spec allows you to pull digested certificates. Does it?
It's well, I think it's a TSM thing. Well, I mean, go ahead, Anish.
yeah, the way it works in CCA is while we do the SPDM kind of commands, everything get cached in the hypervisor, the host. Now, when I say everything get cached on the hypervisor, it is in the hypervisor kernel, right? Now we need an ability to send that thing back to the guest when the guest is requesting for measurements or interface report and things like that. The way it is currently plumbed in my patch series is it comes all the way to VMM. The guest would request, it will come to VMM. VMM will make a guest request IOMMUFD IOCTL, and it comes, and then the guest request is the one that's returning back from the TSM callback, because TSM knows the guest knows the object type. The TSM call backend driver knows the object type. So the guest request for an object type 1, the TSM backend driver knows what is the object type and send back through the guest request. Now we could do alternative mechanism, but I thought like an IOCTL is a nice interface for getting that back via VMM.
It is an interface. And I don't want to rock the boat too much, but I'm just asking the question, like, why do we need to write the code to do this transfer for the CCA case? It has an ioctl. It's going to be transferring certificates and interface reports, and then we implement the same ioctl. It's going to be doing something a little bit different for the AMD driver, and then same ioctl, different ioctl for the Intel thing, doing the same thing, same bytes, same bits.
I get
It's
that,
just a
yeah.
patch for AMD now. So.
It's a what?
CSFS.
Well, but I mean, like, but yeah, it's every like the kind of the whole point was to not to
Yeah, we need to have some interface is what I'm saying. So,
yeah we need to
if
do
we
some
can,
interface.
I wouldn't bother IOMMUFD with it. I would export something from TSM, and this netlink thing, it's talking to a TSM, right?
yeah,
Yeah.
it can be a generic
But
TSM object, one of generic TSM kind of a callback. Uh, but the challenge there is, how we are getting in VMM, right? So from VMM I need to get to. So that's a challenge. So what is the
wait,
descriptor I use?
you already have proposal to do netlink in the guest, right? Guest TSM.
I mean, so this netlink interface is available in both, but I can go back to the code, but like so, but on the host, you can
The
grab
same?
the same like I mean it's the same API, right? Like it is maybe filled out differently. So like on the host, you could say, hey, give me all the certificate slots. That's a host thing. But on the VMM, if you ask for anything besides slot 0, it's going to say no. There's no such thing as any as other certificate slots. Guests don't get to pick slot. That kind of thing. It may be the case that that let's take device measurements. 16 megabytes of device measurements where we don't want to have to implement 3 different. Every single vendor has their own reinvention of 16 megabyte blob transfer. We could have a common way to ask and inject.
I thought that's what Anish is asking. Like, let's not invent ioctls or IOMMUFD guest requests to fetch these certificates on the host to QEMU. So QEMU could inject them into the guest memory, and then guest TSM will report it to guest user space.
I think that
Why don't we use netlink for both?
I mean, we can. The netlink is the guest kernel to guest user space, but we still need something that is VMM to guest, and I think that is what AF VSOC is. So not netlink, but AF VSOC.
Why? VMM is user space, and there is TSM on the host. Just
VMM is, but like, what is the mechanism that QEMU is going to use to tell the guest here's the blob?
And that would be platform specific.
But that's what I'm saying. Like, does it need to be platform specific?
Yeah, so we already have that as a part of the spec.
It does have to be platform specific because GHCB is platform specific, and that's how I'm gonna get them.
Yeah, in my case, it is RHI. So the guest would issue an RHI realm host interface to come ask the VMM to get me the data. So that definitely needs to be platform specific. Now the question is from VMM, how do I ask the hypervisor kernel to get me the data so that that platform specific way we reached can give a response back via platform specific mechanism?
Right. I mean that piece is just netlink. But I'm asking the question about, like, yes, we need guest to host message interfaces for all the different things that are that are actually implementation specific, like the way you ask the ABI to ask the TIO firmware to say, hey, what is the hash of the measurements? That's different than the call, and that's a trusted call that is not that the VMM can't see and can't interrupt. All these other RHI hypercall thingies, those are things that the VMM is free to. Those go over shared memory protocol, right? Those are things the VMM can corrupt and change and do anything it wants to. And so, why do we need? It's a question about why do we need 3 of those?
I think I get what you're saying. You're saying that why should these, whether it is TDX, SNP, or CCA, why do they have this mechanism instead? Why can't the guest use AF VSOC to get this blob from the hypervisor?
In a common way,
like in a common. Okay.
I mean, I think we'll still need probably IOMMUFD guest requests for like bind and other kind of things that have things that touch IOMMUFD, but I worry that, like, we haven't got to the point where we've proposed to Jason, hey Jason, we need to send random opaque blobs through IOMMUFD octals and he's like, why? Because this is the you know what I mean? Like it just doesn't feel like
No.
good
In this
solid
case, we
ground.
wouldn't be exposing this stuff from IOMMUFD. TSM would export it to QEMU. It's digest which will go through IOMMUFD.
Yes, digest will go through IOMMUFD. Yes, because that's a secure path. That's a path that's
Right.
opaque. You have no idea what's in there. Yeah.
But that would be encapsulated in guest request messages. Like in my case, it's encrypted message, so IOMMUFD doesn't get to know what's
Doesn't get to
inside.
know.
It's just info, and it works as a transport, so he doesn't need to worry.
So, I mean, so I might mock that up. Like, I mean, I don't want to change directions here. Maybe it's a bad idea. Maybe there's other reasons why we shouldn't use a common transport for that. But I might mock it up.
So AFVSOC will also have like the same evidence type which the guest would ask.
Well, so yeah, so AFVSOC is not even the guest kernel doesn't even need to be involved. That could just be guest user space talking to. I mean, wait, if it's talking to the guest kernel, but it's
so
it's
we do have a
independent of.
problem there. I need to be in the guest kernel. So here's the thing, right? This cache is coming from the host. Now, before I can trust this blob, the guest kernel needs to ask the firmware, give me the digest which you saw, digest of the message which firmware saw, right?
Yes.
And
Yes.
then the guest kernel would compute the digest of itself. In case of AMD, I think it's user space, but in my case, I'm computing the digest from within the kernel and then comparing the digest that the firmware returned and then making sure that yes, the blob I got back from the hypervisor via the non-secure channel, right now it is an ioctl, is indeed what the firmware saw during SPDM get measurements and other kind of like message flows, and hence the guest can trust that blob. It's not manipulated by the hypervisor nor the VMM. So we can't get the guest user space directly get the blob. We need to have a row because the guest user space cannot get the digest. But then what one way of looking at that?
Well, the guest would get the. I mean, so the guest would get to. It just come in through two different paths. So like, guest user space knows it locked the device. It knows it needs to ask whatever this common interface is to get all the raw untrusted blobs, and then it needs to ask the TSM layer, TSM netlink, give me the digest, give me the trusted digest, and then user space can do the comparison. I don't think the kernel needs to compare anything. It just needs to.
Yeah. So the reason why I ended up doing that in the kernel is so there is a sequence, right? Now the host can issue lock, unlock, get measurements, anything to the firmware, right? Host has the API to do that. Now there are certain things we need to make sure when the guest is when somebody is asking the guest kernel for measurements, we need to make sure that the measurement block that we got is the one actually collected after the lock request, right? After the lock is actually done. So what I do is I know I did issue a lock, but then I'm not sure the get measurement is the one that is collected after the lock, or it could be something that got collected before the lock and host is just returning me back and doing all sort of weird thing, right? So there is a sequence I follow, right? I do lock, then I get the lock sequence number, right, from the firmware. Then I do the get measurements. Then I do the lock sequence number. Make sure that this lock sequence number is same as the lock sequence number I got after the lock, right? So all these sort of sequence comparison happens to make sure that nothing is tampered anywhere and it is indeed the measurement blob I got after the lock, right? And the same sequence number I used during DMA enable also to make sure that I am enabling the DMA using the same sequence number with which these things are collected, right? So what I'm trying to get to is we in the get measurement path, the guest kernel may need to play a role, just to make sure that what I'm getting is indeed correct. So if I bypass the kernel while fetching the blob from the host and somehow expect the guest user space to validate everything, I'm not sure like how you see. I mean, I could think about it, but I think we would have some challenge.
Okay. In in this sequence, so you jump to my next topic, which I think is good. In this sequence number compare step, that is it the case? Can you see my highlighting?
Yeah.
Okay. So when you say that you pass, you want to use the same sequence number in the enable DMA command, that if so, so in this sequence, let's say you get measurement, you did your compare here, and then in between this and enable DMA, the host unlocked and locked again, and changed measurements, whatever, behind your back.
Yeah.
This sequence number you pass, the actual, this is safe because when you go to tell the TSM, hey, please enable DMA with the sequence number, it says, that's not the sequence number. Is that how it works?
Yes,
the final,
exactly. So it's not
final
one sequence number. Enable DMA actually take 3 sequence number. One is the log sequence number, the report sequence number, and the measurement sequence number. All 3 has to match. So if somebody did something behind the back, like the host did some mischievous thing, then the DMA enabling will fail. The guest has to refetch everything, validate everything, and then So if the host did an unlock, the lock sequence number will change. Since enable DMA will not work.
Why would the report change? Like,
yeah,
why is it by itself?
Yeah, the report doesn't have the big significance. It is the lock sequence number and the measurement sequence number, which we need to keep in sync.
Okay,
I think it's
but
the report is just added. Yeah, yeah. I also didn't find why would we need report sequence number. So it doesn't change.
Okay, so I mean that sounds complete. Alexei, tell me about the new TDI-ID method that you say is gonna. Is that equivalent to this? Is it basically saying this TDI?
When I bind in the first place, host will ask PSP. PSP will generate this TDI ID thing, and then all guest requests from the guest to PSP, those encrypted and trusted ones, they have to be with this TDI ID guy. And this TDI ID increments. I think now it increments every time you do bind and bind, and it's a global counter. So if hypervisor behind my back replaces one TDI with another TDI, that will increment, and then my guest request will just fail.
Okay, but it's not
I don't get. Yep.
And if the same TDI is unlocked and locked by the host hypervisor,
it will go through like TDI bind ABA, and it will change TDI ID.
Okay.
But it's not like the actual guest BDF that QEMU is emulating changes.
We're replacing guest BDF with this TDI ID thing now.
Okay. So guest BDF is still a thing. It's still that's still static, but this TDI ID is only for TSM communications.
Well, like encrypted guest requests don't get guest BDF anymore. It's for GHCB, like VM to hypervisor ABI, which is untrusted anyway. And it's to find the right TDI in the host to talk to the PSP. So, in secure protocol, no more guest BDF.
Okay.
So how do you make sure the get measurement you got is the one after the? Okay, so the get measurements would have a TDI ID, and it will make sure that the measurement is after the log.
The thing which returns digest. It will only return anything if TDI ID is right.
Okay, makes sense.
So I don't think it's in. I think it's still. I think so. TDI ID you said is a future thing. I think TDX is also doing a future thing and it sounds most like this TDI ID thing. So I'm hoping that TDX is the exact same thing. But I think my biggest question is that we don't need to do this kernel compare, right? That it doesn't matter how many times the kernel checks it before we try to say it's good. It can still change, and we have to depend on this thing to say no.
Yes, but then the kernel should also need the ability to make sure that the measurement is indeed the one that is collected after the lock, isn't it?
Well, no, I mean, no, right? Because so the kernel said, "Hey, verify, here's a measurement," and the verifier trusts that even after it verified it, it knows that it trusts the TSM to reject its acceptance if it got invalidated. Like that's part of the trust.
Okay, I got what you're saying. You see, you're saying that we will let everything go on, and we will the checkpoint is enable DMA. So the verifier can verify, attest everything, and when the enable DMA fails, it is an indication that something went wrong. The guest kernel doesn't tries to make it extra correct in the
It is right. It
earlier
doesn't
in the
treat you.
path.
Yeah,
Yeah,
that part of what the relying party is attesting to is I trust my TSM to
yeah. I
honor
mean,
my
this
acceptance.
is also similar to the request for carrying the sequence number in the SUP, right? So you are there also. I think your thinking is the same in that SUP will work with whatever,
Whatever
right?
you
I
got.
mean,
Yeah, yeah.
yeah.
You accepted, and you should have. Yeah, you have to trust your TSM to get it right.
Okay.
Um, but okay. So related to this, real quick though, is you do enable DMA before a run
No, after
or
run.
after run?
Yeah.
Alexi, same question. Do you do enable DMA before or after run?
After run. First I do run, then I enable DMA.
Okay. So two votes for that. We're gonna and Elon, is that what we're doing also?
I think currently we first we enable the MSM run, but I remember there is the suggestions that swap this sequence. So I believe in the future we also need to run and enable DMA.
Okay. I think that somebody was concerned, like, oh, if you tell the device to run and the DMA is not enabled, it can see faults. But I think you have to trust that that you shouldn't do that. You should that the host kernel is responsible for making sure that the device doesn't actually start running until it's also done the enable DMA step. So I think that's under the kernel's control. I don't think we need to worry about, like, if a device decides to immediately start trying DMA as soon as you tell it to run, even though you haven't bound a driver or done other actions to it. That's kind of a silly device. And so I think, yeah, I think we should make sure that we're going to switch this.
Yeah.
Okay. Okay.
But
So
does
last
that
5 minutes.
really matters? Does that really matters? The sequence, what the sequence is, because to the drivers, this is some details about the device core. Is it? It didn't. The driver didn't see first enable DMA, second round, or first round. Second enable DMA. It just sees accepted or not. Is it?
Correct. Yeah. I don't think it matters for the drivers. I think it matters for the kind of TSM subsystem being able to describe the security model to the rest of the kernel. So if somebody says, like, at what point is my device my trusted device expected to start touching private memory, and and we tell, it's like we want to have a coherent story that it's always the same sequence, that the device will be told it is allowed, and then the kernel will actually allow it, such that if if you fail in between there, yeah, that like, yeah, failure cases, exception cases, we don't have to worry about, oh, hey, by the way, we did it in the reverse order on this one architecture versus the other one, that kind of thing. That's always the same.
Yeah, but if you don't do either step, if you don't do either step, the device cannot access the private memory. Yeah.
Right. I mean, look, so I'm saying like if let's say we fail at this step in the middle here.
Yeah.
You want it to always be the same error handling in all cases. Like you don't want it to have to be like, oh, the error handler for the TDX thing needs to swap things around because it's different.
Okay.
Like, I mean, so you're right. It probably doesn't matter, but like I think I've actually have people ask that question, like, oh, like is it okay to run before enable DMA? And basically the answer is yes, it's fine. AMD and ARM are doing it. We're okay.
Okay.
Is there something in place that blocks someone from trying to use that DMA? So the only concern I have here is you put the device in run, something goes, oh, the device is in run. I'm gonna try and poke at the memory, but you haven't gotten to the enable DMA yet. Is there something that's going to kind of lock both of those to be done before user space can submit a workload to the device?
Well, I mean, so user space is expecting that the that the accept phase happens while the driver is detached. So as far as user space is concerned, the run and enable DMA happen before any driver attaches. But you're right, a device could decide as soon as I see the run command, like let's say it's an adversarial device, and or just a bad or just a broken device. It could start issuing DMA as soon as it sees run, and it will trigger IOMMU faults and those will be like probably unhandled things and things will go badly. But that's just a bad device, and you shouldn't have trusted it, kind of thing. But yeah. So the user space control is don't bind, but it is you prevent it from binding a driver between those two steps. Okay, so on the IOMMUFD DMA buff strategy, we don't have much time to talk through. I mean, maybe this should probably be a full hour discussion. There's this patch set from okay. Has everybody seen this patch set from Jason? He was thinking that this one is maybe I'll put that in the that this is a prerequisite to go and build the DMA buff to KVM hookup. I haven't had a chance to go through it. That's kind of next on my list. But I think right now, if we had this kind of the last dependency, and this is something we got to talk to Christian about.
That was the plan, right? I think I think Yulin's patches had the dependency of PFN based IO DMA buff kind of interface, and I think the patch series that you just quoted is the one that is getting it all correctly, so that it can also be like PFN based, not just DMA DDR based kind of DMA buffs. So whatever we are doing for.
Sorry, go ahead.
Yeah, whatever we are doing for TSM needs to be based on top of that one, isn't it?
Okay. Yeah, I think so. But you're right. Like we don't have to wait for this one because we have a staging tree. So I could go ahead and pull these in.
What does this patch do? I'm on my phone and I cannot really open it.
I believe this is defining a protocol, and like lifetime rules about tying things to physical addresses and not DMA addresses like DMA buff.
I'm asking because like when 2 months ago, I rebased my stuff on 619 RC, whatever you have in staging. Yulin's patches didn't work because this KVM VM attributes. Now it's like under rework and migrating to IOMMUFD. And now it appears so that Sean Christopherson wants GMMFD to handle VM memory attributes for this DMA buffer as well. So there is new variable. So we need now, because now currently my hack is just to put set the bit in KVM, not in GMMFD, but we need to do GMMFD.
Yeah, I think this is the confusion I had also. Like, there is this lot of discussion around who owns this guy, right? As in like GMM or like things like that. So if we can even put a branch with whatever, I think if yeah, whatever is the one view, right? So that others can look at that view from a TSM point of view, we will have one branch which is at least working on one architecture. And then others can look at, right now I have been punting this and there are some lifecycle issues with respect to unlock and then MMIO kind of a thing. So if we can have one branch with which kind of works on one architecture, others can look at it. It doesn't need to be staging. It can be a separate branch also.
That be staging.
I just learned about this morning, so I didn't prepare any patch, and I still have to do this IOMMUFD GMMFD thing, the mapping from.
I saw the patch. I saw, yeah.
So I need to buy a bunch of hooks from GMMFD to IOMMUFD to notify about things, and that's my priority one. If someone has cycles, you can do DMI buff plus GMMFD thing. And address VM memory attributes thing.
I think then that is the other open point we should write about how is there a TSM specific understanding needed of who manages the secure IOMMU, right? Like there is this notion of IOMMU, GMM needing callback so that whenever a page moves from shared to private, private to shared, does it need to go to IOMMUFD or, I think maybe not really the TSM, but I think at least a CCA kind of landscape. I think that's one thing we need to solve across all the three architectures.
Is there a thread about this already? Like where the GMMFD folks?
I think Alex.
Okay.
Mapping GMMFD and IOMMUFD, yes. Doing VM memory, KVM, VM attributes for VFI in GMMFD, no thread.
Probably is not secure MMIA alone. It is also about generally who manages secure IOMMU. From the point of view of like, I think TIO needs the ability because IOMMU is one IOMMU, and I think Alexei has the need to kind of drive that IOMMU updates when the GMMFD transition. But I don't have that because for me it's a stage 2, and I think it's true even for TDX because the secure IOMMU uses the same stage 2, and if KVM unmaps things from stage 2, it goes away from IOMMU 2, secure IOMMU 2. But that's not true for Alexei. It's a different table for Alexei. Right, Alexei?
Yep.
Yeah.
And I guess the question is, is this, I mean, is this something that you need help with, Alexei, or are you trying to, are we trying to say like that we think that whatever we build here, everybody should use it, even the TSMs that have a stage 2?
Or it should not force that usage. What I'm more worried about is, it should not unnecessarily create some tracking or things on architectures which it doesn't need to. Because I think there is a desire for GMM to track now a lot of these things, whereas on architectures which it doesn't need to do anything, why do we even bother about tracking?
Okay.
I'll do that thing.
Yeah.
Post it and see how that goes.
Yeah, post it, see how it goes, and let us know in Discord so we can either watch the popcorn and pop popcorn and watch you struggle, or we can try to help.
But like I would appreciate help with DMA buff to GMMFD thing.
So, well, the DMA buff to DMFD, but also DMA buff to KVM, which is what that was Ilune's original patch.
Exactly.
So, Ilune, I'm assuming you plan to get back to that and want to rebase everything, and you're going to be our savior there. Is your plan to still be our champion?
Yes,
Can you get
please.
back
yes.
to? Okay.
Thank you. Thank
Okay.
you.
So we'll leave that piece on Eunice's plate, but then yeah, I need to get much smarter about SIG and this IOMMUFD problem. So help me out there, and we can go from there. But in the meantime, I think I'll start pulling in these things that we think are dependencies, like this patch set, and then either let me know when you have the next proposal ready for KVM thing.
Yeah, I think currently what I can do is just the same as before, just to reflect the code, but the functions is not changed. The one thing maybe is missing is that the current my current implementation of this DMA MMR DMA buff is still not considering a private or shared attribute. That is something maybe missing here for secure IOMMU setup.
Yeah,
And
but Elon, what?
currently I don't have clear idea on that if we
But
really
Elon,
need it.
if you can put whatever you have in a branch on top of whatever NVIDIA is working on, right? I think NVIDIA is doing quite a lot of things between VFIO and IOMMU for making sure things can kind of the lifetime rules are managed between VFI and IOMMU. I think our changes has to come on top of that. So if you can get a patch series which is coming on top of that patch series, which is what Jason would want, I think that's a good base to start, even if it doesn't do everything.
Yeah.
Um, and
Agreed.
okay. Currently, what I have is something that already in the mainline. It is the exporting. It is a private channel that exports the DMA buff, and my implementation is based on that. It is a private channel between IOMMFD and the VFIO, and what the link here is an IFC that did it another way, that it makes it standard DMA buff channel that exports the physical addresses. I don't have, I didn't adapt this approach
Yeah,
yet.
I think what we
So
need
what's your
is,
expectation?
yeah, I think what we need is based on top of that RFC, right? Because I think from the community point of view, there is a desire to move to that RFC. I think I have seen multiple revisions of that.
Oh,
So if we can
okay.
get TSM DMA buff on top of that RFC and we can host it in a branch, it would be really nice.
Okay,
Yeah,
okay. So it needs some time because I didn't have code now
that's fine.
for
That's
this
fine. Yeah.
IFC. I didn't. Okay, okay.
Yeah. I think you have 12 hours. So no. Like whenever you get to it, I mean, like I think it's uh I mean, Jason stuff is still in RFC, but certainly like I think Jason would be like, why aren't you building on top of the thing I built? And I think the more we can um, keep that momentum going,
Mm.
Jason will help us with other things. So, but yeah, okay. So I think it's a plan. Like
Previously, the private channel is also Jason's the band-aid. So yeah.
Yeah. I think yeah. We can so we can talk with Miguel. Yeah, we don't have to guess too. We can ask like, hey, um, what would help the most? Like redoing the private channel version as an example, or moving to the final thing. I think I know the answer. I think he's going to say move to the final thing, but we can ask and get more clarity. But
Yeah,
certainly,
I think
that'll
it's
take more time.
correct to move to the standard DMAP of channel. Yeah, move to
Okay.
this IFC. Yeah.
Okay. Well, yeah. So I will get the I'll get the staging tree rebased on RC2. We can go from there. Yeah, I think I'll pull this one in. This is relevant for TDX, but I don't think it's not relevant for anybody else. But Sean did move VMX enabling into his next branch, and so I'm going to pull it into staging 2. It also reworks SEV, but I don't think it's going to impact anything you're doing, Alexei. But it's important. We need it for TDX, otherwise we can't talk to our module from the PCI core. But that's the last thing. Yeah, thanks for staying over there, everybody, a little bit longer.
One last comment.
Sure.
Small one. Turns out I can do cbit and DMA handles, just like everybody else. If I disable this VTOM, via IOMMU, all that stuff, and it still works.
It still works?
Now I'm rethinking the whole thing. How I do this
well,
fees to DMA and back and.
Okay, cool. Welcome to the party of people that
yeah
that don't have a cbit. Okay, cool.
Cheers.
Sounds good. Okay, yeah. Thanks, everyone. We'll talk to you all at the next one.
Okay, thank you.
Thanks.
Bye.
Bye.
Bye.